Today's lesson, section 4.1a, we're talking about exponential functions. So exponential functions are going to be a function with a base a and is defined for all real numbers x by f of x is equal to a to the x power, where a is greater than 0 and a cannot be 1. Okay? Now, a couple things with that. A just needs to be positive, so if it's negative, then it really doesn't hold the same kind of function to what we're talking about. Now, you can tack a negative on the front, that just flips it, but for it to be an exponential function, like either going exponentially greater or decaying exponentially, a value needs to be greater than 0. Okay? Also, the reason why it can't be 1 is if you plugged in 1 where a is in that function, you'd have 1 to the x power, and so 1 to the x power is always going to be 1. So you get a horizontal line at 1, okay, which is not exponential in either direction. So it's kind of like a trivial function that we really don't want to be in the same family as exponential functions. Okay. Now, first thing we want to be able to do is to evaluate. So let f of x equal 1.5 to the x power and evaluate the following. So if I say f of 3, then for f of 3, remember you plug it in for that x up top. Okay, and then you're going to have to plug these into your calculator for like a decimal like this. If you had like 2 cubed, then obviously that would be 8. But here, since it's a decimal, plug it into your calculator. It gives us 3.375. If you would like to, I'm sure that we'll probably be rounding, so 3.4 would be good, or 3.8. Or sorry, 3.38 would be good as well. Here, if I want to do f of negative 1, okay, so then that's almost like, remember, flipping your fraction. So 1.5 is like saying 3 halves. So if I do to the negative first power, negative first power always flips that fraction. So that'll give me 2/3. Your calculator will say 0.6 repeating. Okay, so you could use that as well. Then for the last one, if I want to plug that in, 1.5 to the square root of 2 minus square root of 3 power, then that one definitely you need to plug into your calculator. Make sure you use parentheses so that you can include both. Don't just type it in next to the caret button, because you only do the square root of the power of square root of 2 and then minus everything by square root of 3, which is not what you want. So then that gives us 0.7 or 0.879, so we can say 0.88. Okay? Alright. Next, we would like to be able to graph. Okay? So exponential functions, when we graph, now for this one I'm going to show you several points, but realistically, when we graph these, we really only need 3 points to graph an exponential function. So kind of like a parabola, it kind of has a set determined kind of shape to it, and so we don't really have to go overboard with our points. But I'm going to show you like more than 3 just so you can get a good idea of what it should look like. Okay, so if I start with 0, and I always like to start with 0 with these exponential functions, 10 to the 0, remember, is always going to be 1. Now I would like to go in both directions from there. So let's go with those. So 10 to the negative first, remember that's flipping it, so that makes it 1/10 or 0.1. Okay, and then 10 to the negative second would be 1 over 100, which is 0.01. Okay, and then 10 to the first would be 10, and 10 to the second would be 100. Okay, now I'm not going to graph 100, but you get the kind of idea. So if I graphing this, 0, 1 would be right here, And usually your points will cross at the y-intercept of 0, 1, unless there's other operations being applied to it, which we'll look at. Then also 10. 10's all the way up here, up by the each word, and then the rest of them are going to be pretty close to our x-axis. Okay, so when I graph this, okay, so they kind of have a picture that looks like that. Now it also says state the domain and range. Now here, if you look at our domain and range, domain, there really wasn't any restrictions on what x values I could plug in, because it also says any for or as x is all real numbers, so my domain should be all reals. Right? So from negative infinity to infinity. My range, though, it doesn't look like, if I continued in the same fashion as going to -3 as my x, and -4 as x, and -5 as x, my number continues to get smaller and smaller and smaller, but I never actually get to 0. I just get numbers really close to 0. So my range value is, there's 0 is the lowest point, but we're not going to include it because it doesn't get there, and then to infinity, because obviously, looking at this one, it skyrockets after you get to the positive x side. Okay, let's look at another one. So here's the flip. So if I have g of x is equal to 1/10 to the x power, so let's say those same numbers. So 1/10 to the negative second. Here, that flips it to 10 to the second, which is 100. Okay, and then 1/10 to the negative first flips it to 10 to the first, which is 10. 1/10 to the 0 power is always 1. 1/10 to the first power is 1/10. And then 1/10 to the second power would be 1/100th. Okay, so here it's just kind of the opposite fashion. So we're going in the kind of in the opposite direction. So 1, 2. So my 10, my negative 1/10 is all the way up there. Then 0, 1, and then 1, 1/10, and 2, 1/100th. Okay? So there's my line. And so looking at my domain and range again, there were no restrictions on x, so it's all reals. And the range would be from 0 to infinity as well, even though we're going in the opposite direction. Okay? So graphs of exponential functions are still the form f of x equals a to the x power, where a is greater than 0 and a cannot be 1. So they're also going to tell you that the domain is all reals and the range is usually 0 to infinity. Now I only say usually is because if you're not doing anything to your y values, like adding another number to the outside or doing something to your x, then your numbers will probably, like your range and domain will always probably be the same. Okay, but this is just for like the parent function specifically. Okay, so the line y equals 0, which is the x-axis, is a horizontal asymptote of f. Okay, so there's this imaginary line, kind of like for rational functions, that goes across the x-axis and moves with the function. So it don't think it always stays there. It moves with the function to create that barrier which makes your range not go below it. Okay? And so our graphs of f will usually take the following shape. So you'll either have a, as you move from left to right, an increasing function, which is called growth. And that only happens when a is greater than 1. You will also usually have, or on the opposite side, you will have from left to right a function that gradually goes down and heads kind of towards 0. So this is called decay, and this happens when your a value is in between 0 and 1. Okay, so it's not 0, it's not 1, but it's like decimal values in between those. So you're basically dealing with your fractions there. Okay. So here we want to graph some more, but we want to do it without plotting points. And here I'm going to start using 3 points. And so when you graph these on your assignment, please only use 3 points. Okay, but it's nice if you use these 3 points because it makes it. And I only say this, you don't really have to use these 3 points, but these are the easiest points to graph every time. Okay, so you want to start with where you're at 0, which if you start with a parent function, so 2 to x, and then go to the 1 plus 2 to the x. To the x, if you plugged in 0, you would get 1. Okay, so that's that first one. And then, obviously, if you plugged in 1, it would be 2. If you plugged in negative 1, 2 to the negative first would be 1/2. Okay, so those are 3 easy points to graph. Okay, so basically I want you to use the thoughts of negative 1, 0, and 1 for x. Okay? Now, if your x has something to like being done to it, those values will change, kind of like letter B is, but you'll still end up kind of like our sine and cosine functions. We always wanted to get them to go back to those base x values so that we could get easy numbers. Okay. So here, if I'm changing this, so let's do this one in purple. So if I'm adding 1 to my 2x, everything moves up by 1. So 1/2 becomes 1 and 1/2, 1 becomes 2, and 2 becomes 3. So also notice that our asymptote of y equals 0 moves up to y equals 1. Okay? Because you're adding 1 to it as well. Okay? So our range and domain change a little bit. So our domain will still be all reals, but our range will change from, instead of 0 to infinity, it will be 1 to infinity. Okay? Let's try the other one. So letter B says 1/2 x minus 1. So let's say we graph what 1/2 to the x power would be. Okay, so it would be kind of the opposite. So if you plugged in negative 1, it would be the flip of that, so it would be 2. If you plugged in 0, it would be 1, which is always the case, and then 1/2 to the first is 1/2. So we get that kind of same look, it's just decaying instead of growing. And then if I graph the other one, so do x to the minus 1, that just means my values change. So remember that stuff on the inside dealing with x moves it to the opposite direction as the sign is. So since it's minus 1, that means instead of being negative, it moves it to the right in a positive direction. So because you want to negate it. So this 1 or negative 1 comma 2 becomes 0 comma 2, because if I plugged in 0, 0 minus 1 is negative 1, negative 1 is, or 1/2 to the negative first power is 2, right? And then if I plugged in 1, that gets me 0, because 1 minus 1 is 0, 1/2 to the 0 power is 1, okay? And then also, if I plugged in 2, that got me the 1 that I want. Okay, so here our function moves to the right instead of staying that way. So now here our asymptote did not change, and also our range, our domain didn't change either. So we're still all reals. And then my range is still in between 0 and infinity. Okay? Example 4 here gives you a exponential function of f of x equals, or a graph of a function, and they want you to write the function in the form of f of x equals a to the x. Okay? So you're given a point. So the nice thing about this is you always have this thought where you know that this is x and this is my f of x. Okay? So if I was to write a function in this format, knowing what I know, that means this is 25 and that means this is 2. So I can solve for a. So using my square root, square rooting anything gets you plus or minus, but okay, remember, go back to your functions. Can a be negative? Nope. So we take out the negative 5, so a must be 5. So our function, or our function equation should be 5 to the x power. Okay, let's try another one. So here you're given a point 3, 1/8. So do the same thing. So 1/8 is equal to a to the third. Here you can do the cube root of both sides. Okay. Now remember your cube roots. You can split it up. So the cube root of 1 over the cube root of 8. Now, doing the cube root does not make it plus or minus, it just makes it the sign that it was previously, so it's positive, so it stays positive. The cube root of 1 is 1, the cube root of 8 is 2. So that means a is equal to 1/2, so therefore our function should be f of x equals 1/2 to the x power. Okay? And so those are kind of the first steps to getting back with exponential functions. Okay? So hopefully this is just kind of a review for you, since you guys talked about this in advanced algebra and algebra 2. Okay? Have fun.